Okay, gentlemen. So today we are going to discuss chapter number 8. Chapter number 8 is about schedule compression, or we say it's a time cost trade-off. Time cost trade-off. So allow me to say Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulullah. Rabbi shrah li sadri wa yassir li amri wa hlul uqdata min lisani yafqahu qawli. Assalamu alaikum wa rahmatullahi wa barakatuh to each one of you. So we are going to discuss today chapter number 8, inshallah. It's about schedule compression. So let's move forward with the simple things, inshallah. So it's okay, so let's move with the simple thing. Bismillah ar-Rahman ar-Rahim. So it's time cost trade-off. Okay. So, you know how we are going to deal if we shorten the project like duration. So how it's going to affect on time, or how it's going to have effect on the cost. So usually, as you know that these three things are important in every project. One is scope of the project, like how much is the volume of work or total work of the project. Okay, so scope, and then cost is important. So how much project is going to cost, and third thing is schedule. Time schedule, how long it's going to complete. Okay. So schedule is very important. So now see, it's do not shorten the duration further and keep the cost to a minimum. So when we deal with these things, so if we we want to shorten the project duration, so we are going to achieve optimum time and minimum cost. This is the best when we do the schedule compression, or we do the schedule acceleration. So keep compressing the schedule even though the cost will continue to rise. So if we can also, even if we achieve the optimum time and least cost or minimum cost for the project, but we can still shorten the schedule, but cost will increase. Okay, we can still shorten the duration, but the cost will increase. So sometimes we have we have to finish hand over the project on time, so time is more important. And sometimes we want to keep the cost low, and time is we are okay with time. So it's we have to decide whether we have to give importance to the time, or we have to give more importance to the cost. Time and cost are important in any project. One may be more important than the other. So for anybody, sometimes time is more important on some project if you have to hand over the project on time. Or sometimes usually cost is more important, that people want to complete the project with the least with minimum cost. So you need to make a decision, whether time is more important for you, or is you need to save cost. Okay, so I think this is that you need to make a decision about these things. So let's move forward. So what we said is that for any project, time and cost are these are very important things. Scope, cost, and schedule. Okay. Let me fix some, set the stopwatch so that I should know how long it's going to take. Okay, so schedule acceleration. So we are going to speed up the project. Schedule acceleration is shortening the duration of the project schedule without reducing the project scope. Okay, so it means we are not going to reduce the scope of the project, like volume of work or total project work will be same. So what we are going to speed up the project. So it's we call it a shortening schedule acceleration till reaching the desired duration or the crash duration, whichever comes first. Okay. So we are going to shorten either we reach the desired duration, like how much time we want to save. Okay. So our the crash duration. So we crash. So sometimes we say it's a simple crashing or a complex crashing. So usually we do 1 day in each cycle. So that by this way we do the simple crashing. So that the curve should be like going to shorten in a straight line. Not in a curved way. So let move forward with the simple thing, time cost trade-off. So whether we are going to give importance to the time or to the cost, so how we are going to trade these things. A least cost schedule is one with an optimum project duration such that to lengthen or shorten it would increase the total cost. So it means least cost schedule, it's a minimum cost schedule. So that we want to achieve, if we increase the duration or we shorten the duration, so it will increase the cost. So it means we are going to find a point in the schedule where we can get a minimum cost with the optimum time. Okay. So that is like the best solution we are going to find usually. So what is the objective of this time cost trade-off? Is objective of time cost trade-off analysis is to reduce the original project's duration with possible least total cost. Okay, so this is the objective of time cost trade-off that we are going to reduce the project duration with the minimum total cost. Okay, so we are going to find duration of the project where we can complete the project with the minimum total cost. A cost time trade-off. A cost time trade-off is used to increase the net benefit of a project by crashing selected activities on the critical path. So you see, because if we want to reduce the project duration, it means we must reduce the project duration on the critical path. Okay, we must reduce the project duration on the critical path. So then we can shorten the project duration. So we will see, as we proceed further, we'll see, go in detail, inshallah. So project schedule acceleration usually, but not always, increases project cost and often has physical and practical limitations to how much it can be shortened. Okay, so see, it's like sometimes there are limitations that we cannot go further to shorten the duration. So sometimes it create other problem like project can delay or mess up, or it can affect the safety issues. So we have to be careful when we are doing these things. So when we talk about schedule compression or least cost schedule, so then many different identical terms people are using. They are like similar terms. Some people call it schedule compression, some people call schedule crashing or schedule acceleration. So it's all that we are not going to reduce the project scope. Okay, we are going to shorten the project duration, and sometimes we call it a time cost trade-off. So whether we are going to put more importance to the time or more importance to the cost, what should be the relation between these things. So if we have to meet the deadline, so we are not worried about cost, so we may put more emphasis that we have to finish the project by this line. So it's crashing is more important. Okay. But otherwise cost usually for project manager cost is more important for. So sometimes some people call it a schedule shortening, or some people call it least cost scheduling, like minimum cost scheduling to find the or we call optimum scheduling. Means we are going to find optimum time, like the most suitable time where the project cost will be minimum. Okay. So these terminology, in academics, people use in when we talk about the project schedule acceleration. Some people call it least cost scheduling. So schedule acceleration may be planned before construction start. Okay, so if we plan like for the schedule, we have to follow up the accelerated schedule. So before construction start, we can decide that we have to complete this project as a fast track or accelerated schedule. But sometimes we are behind in the middle of the project, decided in the middle of the project. So we are behind schedule. So we want to hand over the project on time. So we are going to decide that we have to shorten the speed up the project, shorten the duration now. So we call it a recovery schedule. We call it a recovery schedule. It means that we are already delayed or we are behind schedule. So now we are going to like catch up or we are trying to complete the project on time. So we should prepare our recovery schedule so that we can complete the project according to the contract. Why do owner demand schedule acceleration? Here there are various reasons that owners they want a schedule acceleration. So why they want to make sure contractor finish date meet their deadline. So it means owners they want that a contractor they should complete the project according to the signed contract. Okay, so they should meet the deadline of the project to finish the project. To respond to market demands, maximize profit. Okay. So sometimes because they want to open their project early and to rent out that project so that the projects should start giving income, so they want to increase their profit, so that's why they are asking to if the market situation is this that when projects start running, so project will start giving income to the owner of the project. Okay, so they are going to ask for acceleration of the schedule for the convenience of the public. Okay, for some projects we want to shorten the schedule, like road construction. If there is a lot of traffic, on those roads, so we want to reduce inconvenience to the um, you know. Uh, public, those are using that project. So there should be like minimum hindrance, and project should not create problem for the people of that area, to suit their cash flows. Okay, so sometimes we to make profit or to suit cash flows, or we have to shift, go to the next project. So these are like the reasons why owners they demand to speed up the schedule or to accelerate the project schedule, simply to reduce cost. Okay, so now sometimes the owner is asking that prepare the find the least cost schedule so that the cost should be minimum for the project. Okay, so why do contractors accelerate schedule? To meet owners' contracts stipulated date. Okay, so contractor they are going to speed up the project or accelerate the schedule that they can meet the given or agreed date of the contract. Okay. So if they are behind schedule, they need to speed up. Okay. to avoid penalties, liquid damages, and or get early finish bonus. Okay, so see if there is a like a bonus if the contractor will finish early, so contractor can get bonus. Okay, so it means they will try to speed up the project to get that bonus from the owner. Okay, or they are going to speed up if they are already late. So then to avoid any liquid damages, like the liquid damages means the money paid by the contractor for a delay for late completion of the project per day. So then usually in every contract per day cost is given from the owner side, that if the contractor complete the project late, so they have to pay the liquid damages. Cost that contractor has to pay for late completion of the project for each day. So let's next point is to start other projects. Okay, sometime a contractor they want to start a new project. They got a new project, so they want to shift their resources, their labor force, their equipment to the new project. So they want to finish this current project as early as possible, simply to reduce cost or increase profit. Okay, so these are the main reason why contractor so the contractor want to complete the project with the reduced cost or with the minimum cost. Okay, and they want to increase their profit. Otherwise they will avoid paying any money for liquid damages or anything. So now your book is going to discuss a case study that in California, this is some earthquake happened, and because of that, there was a damage and lot of disturbance to the public because of that earthquake. So then it's elevated road. So they let's see, we will read how they manage this project by doing the acceleration. Okay, so the North Ridge Quick on January 17, 1994, a quick of 6.7 magnitude caused heavy damage and high casualties in Northridge, California, USA. Okay. The immediate major concern for Caltron is like the California Department of Transportation, was reopening the public highway. So they want to reopen that public highway that was get damaged due to the earthquake in one of the nation's busiest area. Okay, part of the damaged highway was two sections of the Interstate 10 in Santa Monica. Okay, so there is there is the interstate USA interstate highway, so that was also a problem. So now there was a contractor like CC Myers International California was awarded the contract to repair those sections. Okay. So this contractor CC Myers bid of 14.7 million was significantly below the Caltron's 22.3 million engineer estimate. So see now their engineer, they make the estimate that like the owner, their estimate was 22.3 million. Okay, but the contractor they submitted the bid that they can finish this work under the given conditions with 14.7 million. So owner was very happy, that the bid was very low. And the contract gave the contractor 140 days to finish the project. So under the contract, they have to finish this project in 140 days. Okay, with this contract. So now what happened, because there was a liquid damages clause of 200,000 for each day of delay, and a similar bonus amount for each day of early finish. So see now they in this contract, because owner want to finish that contractor should finish the project as early as possible. So if they get delay from in that, so they have to pay 200,000 for each day. Okay, but if they will complete early, So they will get bonus of the same 200,000 per day. Okay. So now see the way contractor work for this contractor was able to finish the project in 66 days only. So now contract was 140 days, okay, but the contractor was able to finish the project in 66 days, okay. So it means they have finished 74 days early, 74 days ahead of the stipulated deadline. So they have finished the project 74 days early than the given time in the contract. So it means they can get bonus of 74 multiplied by 200,000. Okay. The project was fast tracked. So project they make it like a fast track. So project was fast tracked. In addition, CCMIs worked around the clock. Okay, so this contractor, the project was fast track because usually fast track project, like they can start when before the design is ready, so they can bring forces like in work in parallel, not like in sequence to complete the project early. So in addition, contractor SEC Myers worked around the clock. So they were working around the clock, not like only one shift of 8 hours per day. Okay? So they were working 24 hours a day, putting large number of resources in the project, making this project the focus of the company. So the contractor, like they accepted the challenge that they will complete this project as early as possible, so that the people will get happy, so because there was a problem for the public, because of this earthquake. What also helped was the cooperation between Caltron and the contractor. So like Caltron is the owner, so they also cooperated with the contractor. So Caltron did its part to help push the project, assigning 10 engineers on the day shift and 4 on call at night to inspect work and answer questions. So the owner, they assigned 10 engineers they for supervision at daytime. Okay? And then they also gave 4 engineers that they will be looking after the work at night time if there is a requirement from the contractor side. So by this way, the contractor they accepted the challenge and they were finish this project in 66 days instead of 140 days as the original contract. So they saved 74 days, and you can multiply 74 with 200,000. So it will be like 14.8 million. They got the bonus. CC Myers may have gone in the process of expediting the schedule over their original budget, but with about 14.8 million bonus, they were certainly ahead of the game. Okay. So because they completed the project 74 days early, so 74 multiplied by 200,000. So their bonus was 14.8 million. Original contract was 14.7 million. So it means the contractor earned 29.5 million from this project by completing it early in 66 days, and then the project was open to the traffic. So despite the large paid bonus, Caltron seemed to be pleased with the result. Okay, so owner was also happy that the convenience of the public was well worth the effort and the money. So the owner was happy that the contractor finished this project early, so then the public can use this road, for traffic. Caltron and CC Myers both believe that despite the schedule compression, there was no compromise on work quality. So because they completed the project in early, so in 66 days instead of 140 days. So, but they did not compromise on quality issues. So they maintained the quality. So So this is like everybody was happy with the performance of this system as a contractor. So here they want to give you idea that how schedule compression is going to help for opening of very important projects if and to ease the traffic or to ease make a convenience for the public. So more on project acceleration. Now, see, they are like they are. So one example you have seen before is Northridge earthquake case. Is a project of Coltron and with the contractor of CC Myers. Now they are giving some more examples that there are other projects in the world. There are many projects that were completed with the acceleration. So the tomb of the late Turkish president. Okay. So tomb of the late Turkish president, the royal palaces in Mecca. So this is also completed as an accelerated project. And there was Olympic Games, like Olympic Games in 1976, in 1996, or even Olympic Games that happened in China and Beijing in 2008. So all those venues or projects were completed as with acceleration, with fast construction. So the project top priority is money or time. So we see every time we have to see that whether we have to give more importance to the money or the time. It is true that time and cost are important for every project. However, one must be more important than the other. So then it is one must make the decision whether for him to complete the project early is important or to save money or cost is more important. Okay, so then you see the contractor need to make a decision. What is more important and what is more beneficial for them for the project. How important is meeting the project target finish date? So how it is important that they should meet the deadline of the finish date of the project. Okay? So they should finish the project on time according to the contract. Is acceleration really needed? How much acceleration is needed? So sometimes we have to think, because accelerating projects sometimes it costs money, so direct cost will increase. We need to decide that whether there is a serious need for acceleration or how much we have to speed up. So we need to decide actually. Is the extra cost justified? So if there will be extra cost for early completion, so will that cost be justified? Will be okay? So this we need to decide. Based on these things, we make our decisions that how we should go ahead with this project, whether we complete it as a accelerate the project, or we don't need to accelerate. If we are on schedule, then we don't need. If we are behind schedule, maybe we need to accelerate the project. Methods for accelerating work in a project. So now they are going to discuss that there are many methods that we can use to accelerate uh, the speed of the project. So one is like they are going to say is number one is invest more time and money on planning. So it means do proper planning of your project. If you do proper planning and very careful, accurate planning, so you have spent more time in your planning. So then you can also, like when the project actually start, so you can follow that good plan and you can complete the project in a good way. Contractual adjustments, okay, incentives. So if there are like in the contract, just like you have seen before that project with Northridge earthquake case. So if there is an incentive in the contract that there is a bonus, okay, so then they can complete a project early. Okay, they can make adjustment to get that bonus. Okay. So revisit the schedule. So we need to see our schedule, whether our schedule is accurate or we have not prepared our schedule with the full good accuracy. So then if our schedule is not good, it means it will be difficult to follow. So then we should prepare a very realistic schedule. Okay, that should reflect the work of the project and the completion time of the project. So we should revisit or try to improve our schedule and have a good schedule to complete the project. Now, fast track of the project. Okay, so we can do fast track construction it's a method of accelerating the project. So it's in fast track projects, usually you can start construction before design is complete. Okay. Um, so it's like we can also start activities in parallel, rather than in sequence. So we can bring more contractors, more subcontractors in the project, and put more resources or more people, more subcontractors, so that they can finish the project early. So this is like a type of how we do the project in a fast track way. So then it's the next method we can adopt is value engineering. Okay? Value engineering is like achieving function with low cost. Okay? This is value engineering. Is usually like we are going to complete the project and make revisit all the bill of quantities and all the quantities on the bill of quantities in our project, and see what we are going to do. So without compromising on quality and function. Okay. So without compromising on quality and function, we are going to try to reduce the cost. So this we call it a value engineering, like we put uh, achieving a function with the low cost. Okay. So it's and then we can also put a constructability, constructability like industrialization. So we can use our construction expertise and knowledge at the design phase, and make more standard elements. So usually, like if you go to Madinah al-Munawwara, so Masjid Nabawi, so we see that every column is the same size, So and then this is like when we do the construction, so we try to make standard elements, So this is like constructability or buildability studies that we should build fast if we have standard elements. Like for the metro project, every column size is same. Okay, viaduct shape is same, So when we have these standard things, then we can do the construction fast. Okay? So we can apply constructability or buildability ideas uh, mm, in the design phase, so that we can do construction on a fast track basis or industrialization. So it's like we can bring precast elements wherever possible. So improve communication. Okay, so next is a method that as a project manager, so keep everybody should work in harmony, so there should be good coordination, good communication, make things clear with everybody on your project site. So it's communication is very important, so people will have a very clear idea what's going on. Then we say is work overtime, more worker and equipment, more shift. Okay, so work overtime, we can ask, bring more labor force and more equipment. And instead of working just one shift, 8 hours per day, we can work in two shift, 16 hours per day, or we can work round the clock. Okay, round the clock. So, but if we have to work around the clock, we should have a different labor, not like the same labor. In the next slide, we'll see this impact of overtime on the productivity of the people. So the next method is acquire special materials, equipment, and technologies. So it means we can speed up the construction if we are using good materials, so like you are doing the tiling flooring work or fixing the tiles, so the size of the tile will matter, that big size tile maybe you can fix early, or small size tiles will take more time. So we should use good new equipment, not work with faulty equipments. So this will also reduce our construction time. Or we should have use a good technology and good scheduling, good planning. A good machinery. So by this way, our good construction methodology, procedures, standard operating procedures. So we should use latest technologies to build our project. So another method they are going to discuss is offer incentive to individual crews or the entire team. So they usually they are going to sometimes offer incentive like working overtime or pay extra money if the people they can work a little more to they pay more money to the crews or to the entire team and offer some incentive so that they can achieve do more work, especially concreting work. Activities they are those are critical, so they don't stop. They work day and night. Other work can be like can happen maybe in one shift or something. So in next point, what they are going to discuss method is improve project management. Okay, so we should follow the project management techniques. Or we should have a good project manager. We can adopt many things in our project management related to material, related to equipment, related to the organization, related to the cash flow, related to the scheduling, related to escrow. Okay, so related to quality. So we can adopt many techniques to so that we can finish the project early. Okay, let's move forward next. So here they are going to talk that what's going to affect the work time if we have overtime work and how it's going to affect the productivity. So here, if you see the graph on the x-axis, there is given weeks and on y-axis is given the productivity. So what they are going to say that this graph is 60 hours per week, 50 hours per week. So two lines. 60 hours normally working if we work 8 hours per day, so 5 days a week, 5 days a week means 40 hours per day. So usually if people start working more than 40 hours, so 50 hours per day or 60 hours per day, it means they are working spending more time on the work. Then productivity of the people due to tired or fatigue or because of these things is going to affect. So what they are going to say here is a productivity decline with more hours worked per week than the 40 hours. So 40 hours is the standard, like you work 8 hours per day and 5 days a week, it's 40 hours per week working time. So if you work more, then because this is they have shown two graph with 50 hours and 60 hours. So there is a sharp drop in week number 1 as a result of pattern change, recovery in week number 2 and 3. So in week number 2 and 3, there is a little recovery, but sharp drop, and then there is a recovery. Then gradual decline from week 4 to week number 9. So there is a gradual decline from week number 4 to week number 9. Okay. in both the cases, whether they are working 60 hours per week or 50 hours per week. So there is a due to the fatigue. Okay, means people are very tired and they cannot do productivity. You know, if you have working hours less, so then usually productivity people in with a fresh mind and things not tired, so they produce more. So leveling in week number 10. So then they did the source leveling. So it's like it's flat, you know, in week number 10. So here they just want to say that we should be careful to while we are taking work from our labor force. So they should not work more than 50 hours. It's too much, you know. Even some people they work 12 hours per day. So is too much for them, you know. So standard is that we should work around 40 hours or 8 hours per day. Okay, so let's move next to the techniques for schedule compression. Now there are like what are the techniques that we use for accelerating the schedule or compress the schedule. Construction Industry Institute suggested more than 90 techniques for schedule compression. So they have suggested there are the 90 methods that we can use for to compress the schedule. It further classified them by project phase or function. Okay, so they have classified them with the project phase or function, like ideas applicable to all phases of the project. Okay, so how we have to speed up or do good design during the design phase or construction phase or during the bidding phase. So during the handing over phase, we have to pay attention how we can complete a project early if we pay attention to the phases, and pay attention to the engineering phase. Okay, like the design phase, or there is a contractual, we can adopt which method or which contractual method will help us in completing the project early. So we can use these, or we should pay attention that we have good planning and scheduling, and then follow our plan to complete the project in a shorter time. We should have a material management, there should not be shortage of material, or you know, if the materials are not available on site, so it means labor will be sitting idle. So we should have a good material management. We should have a good construction work management, work procedures, standard operating procedures, and number of crews, number of people in a crew, how many in groups. So we need to pay attention to field labor management. We should manage our labor force in a good way to complete save time on our projects. Okay. So startup phase, okay. So in the beginning, you know, so like we should not bring too many people in the beginning. So according to the work, we start with less quantities in the beginning and less labor force, and then as long as work is going to expand, we bring more people and more equipment. So we should avoid congestion, you know, in the beginning of the project and also at the end of the project. So like these are the method that techniques we use in the schedule compression or to complete the project early. Concept of schedule acceleration. So now what is the concept for accelerating, like speeding up the project? Shorten the longest critical path. Okay, start with the easiest, least expensive activity to shorten. Okay, so it's so we, if we want to shorten the project duration, we have to shorten the duration from the critical path. Okay, and then when we start, so we start with the direct cost activity where cost is a minimum. At a certain point, the critical path will tie with the next critical path. Okay. Shorten both paths. Either select a common activity shared by both paths, or shorten two activities, one on each path. So see, because we have to shorten the project duration, we have to shorten the duration from the critical path. So if there is a single critical path, we will shorten, see which activity have less cost for direct cost. So we will pick up that one. But if there are two parallel critical paths, so we have to shorten duration from both the part, then we can reduce the duration of the project. So it's we have to pay attention to the both the path. So how many paths are there? Every from then we have to shorten each path, because if there are more than one critical path, because in the network schedule there could be one critical path, or maybe two critical path, or three critical path, or maybe more. So each path we have to shorten to shorten the project duration. At a further point, the two critical paths will tie with the next critical path, shorten all three paths, and so on. If there three paths become critical, so we have to shorten all three paths to shorten the reduce the project duration. Okay, it's not possible that we reduce duration from one path, but we are not going to reduce the duration from the other critical path. So if there are two critical paths, from each critical path, we have to reduce the duration from each critical path. If there are three critical paths, so we have to reduce cut from all three critical paths. Stop when you achieve desired duration or when the project is completely crashed. Okay. So we will continue that either we are going to achieve the desired duration, that duration is suitable to us for handing over the project, or we crash as much as possible, like so we consume all the total crashing from, the total crashing until according to the situation. So when we solve the numerical problem, then you will see, so like here they are going to put make it easy for you, this schedule compression multiple, there is a path, okay, so like there is a multiple path, number 1 2 3 4 5 6 7 8 paths, okay, 8 paths, and the number of days. So now we can see that path number 4 is critical, red bar path. So if we reduce 2 days, we can reduce 2 days, day number 26 and 27, 2 days, so we can shorten the project duration. Okay. So first we have to reduce 2 days from path number 4. Okay. So then the shape will look like this way. Okay. So it means now path number 4 and 5 both become critical. Okay, path 4 and 5 both become critical. So if we want to shorten the project duration, we have to shorten project duration from each path. Okay, from 2 days from path number 4 and 2 days from path number 5. Okay, then we can shorten the project duration. So if now when we shorten the duration from 4 and 5, so then we can see that path number 3 also become critical. So now in the current situation, so there are three paths, path number 3, 4, and 5. 3, 4, and 5, they are all critical. So we have to reduce the duration from each path to reduce the duration of the project. Okay, so reduce 1 day from each path number 3, 1 day from path number 4, and 1 day from path number 5. Then we will be able to reduce the project duration. Okay, so it's and now when we reduce this in the next step, now there are the 4 paths become critical. So now see now next path number 1 will be becoming critical. So it means we have to reduce 2 days from path number 3 and 2 days from path number 4, 2 days from path number 5, and 2 days from critical path number 6 to reduce the project duration. Okay, so like next we have like situation like this way. So now the 5 paths, path number 1, 3, 4, 5, and 6, they are all critical. Okay, so this is the way that we have to deal with multiple paths when we do the schedule compression or least cost scheduling. We want to accelerate the project. Okay, so affect the project acceleration on cost. Okay, so it's see, it's how it's going to affect the direct cost like cost of material, labor, and equipment. Okay, So increases at an increasing rate. Okay, so direct cost always increases. When we shorten the project duration, so we have to bring more resources. Like before, we were working with one crane. Now we have to work with two crane. So we have to increase the resources. Okay. So by this way, direct cost always increases, if we shorten the duration. And then indirect cost is usually is constant for each day. And when we reduce the project duration, so indirect cost will decrease. So similarly, we will add a direct cost and indirect cost and see the total impact on the project. How our curve is proceeding, watch the curve go down or up. So when we add up these direct costs and indirect costs and see what is going to happen with the total cost of the project. So say for example, now here they are going to mention this is the curve for direct cost. Okay, so direct cost is schedule compression if on x-axis is the duration, on y-axis is the cost. So if we reduce the duration, so you can see the cost is going to increase. If here the cost is at this point. So as long as we reduce the duration, so cost is going to increase with the shortening of the duration. Direct cost is always going to increase. Here is the indirect cost. Indirect cost is a linear relationship. So if we reduce the project duration, so this on x-axis is the duration, y-axis is the cost. So if we reduce the project duration, so indirect cost is going to reduce. Indirect cost, like there is a, if metro project could have been completed early, or if it's uh, delay for one more year, 2 years, so then it means you have to pay cost will going to overhead costs are going to increase. Also because there are the offices there, engineers are working, petrol, so all these things, site offices. So indirect cost is if we shorten the duration, indirect cost will decrease. Okay. So now we see the impact of both. Okay, we add direct cost and indirect cost and see how the impact look like. So now on the x-axis we have the duration, y-axis we have the cost. So we can find like when we combine these two, so we can find like this point is the least cost schedule or minimum cost and optimum time. Okay, least cost duration. Okay. Least cost duration, where we have the least cost and optimum time, or the minimum duration and minimum cost. Okay, so most suitable time, least cost duration or least cost cost. Okay. So if we, like at this point, if we shorten the duration, cost will increase. If we increase the duration, cost will increase. Okay, so this is like we are going to find the optimum time where project give the lowest cost. So it is okay. Why does acceleration increase the direct cost? So this we have discussed before in the previous graph. Cost will increase with the acceleration. Okay, direct cost will increase with the acceleration since more resources must be allocated to accelerate the project. Okay, so we need before we are working, we have sometimes we have to increase the labor force. Sometimes we have to use more material or bring more equipment on site. So direct cost will increase. Why does direct cost is going to increase if we accelerate the project? Because we need more resources. Okay. So we start with the least expensive activity to crash. When we do the crashing, we start with that activity where increase in direct cost will be minimum. As we crash more, our options narrow down and get more and more expensive. Okay, so yeah, this is as we go with the crashing more, so Then it's after once we have find out the minimum optimum time, but if we shorten more, so then cost will increase. When we start accelerating one activity by 1 day, usually results in shortening the project duration by 1 day. As we progress and critical path tie up, we will need to crash several activities, each by 1 day, in order to shorten the project duration by 1 day. So if there is a one critical path, we have to shorten one activity. If there is two critical path, we have to shorten the duration on each activity on each critical path. This is the way that we can do the acceleration. So now they are going to put a numerical question. Actually, in the class, I saw this on the board. So that was easy to understand because you can see how the things are going to happen with your diagram and with your situation with the graph and with the schedule. But here now to explain it online, it's little difficult, because on the board, the schedule is in front of you and so, but anyway, let's try. So given data is given that there is a activities A, B, C, D, E, F, G, H, okay, and IPA list is given. Okay, then there is a normal duration is given and crash duration is given. So normal cost column is given and crash cost for each activity is given. Okay, so this is the given data. So if we know the activities and we know IPA, so we can draw the diagram. So we can draw the node diagram. Overhead cost also given 120 real per day, or dollar per day. Here is dollar, so we can also assume dollar on this side. So we are not concerned too much with the units, but in your exam, so I will give the currency will be real, and so the real in our exam problems. So its overhead cost is 120 per day. Okay. This is also given. Now, if we see this, if we have in front of us our schedule, we can draw the network diagram like this way. So activity A, duration, normal duration is 5 days, and that's the IP is nothing for this activity. So it means this is the activity A, normal duration is 5, IP is nothing. So it means this is the starting activity. Activity B will be after A with 7 days duration. C will be after A with 8 days duration. D will be after A with the 11 days duration. And E will be after B and C with 6 days duration. F will be after C with 4 days duration. G will be after D and F and 7 days duration. H activity will be after E and F with a 6 days duration. Okay, so we can draw this diagram. So activity A, the starting activity, 5 days duration. B is after A with 7 days duration. C is after A with 8 days duration. D is after A with 11 days duration. E is after B and C and with the 6 days duration. F is after C, 4 days duration. H is after E and F, so with 6 days duration. G is after F and D, so with 7 days duration. And then these two activities in the air, so we put a note by ourselves called project finish point. Project finish point. So we draw the diagram and then we put these duration, normal duration inside, and then we can do the forward pass and backward pass and find the critical path. Okay, so this is like because here are not shown these things, so this you have to do by yourself. Like here, if we put a 0, 5, then here this 5 comes here. 5 plus 7 is 12. Then this 5 plus 8 is 13. And from here, from A to D is 5. 5 comes here. 5 plus 11 is 16. So then B and C. So both should finish, then E will start. Okay. So then B finished 12, C finished 13. So 13 will move the when we move forward, so we take the highest. Okay. So both should finish, then E will start. So 13 plus 6 is 19. Similarly, from this 13, 13 comes here, plus 4 is 17. So here from E and F, one is 19, other is 17. So then for H is starting point is 19, plus 6 is 25. Okay. And then for G is after F, so 17 here, 16 here. So we put 17 plus 7 is 24. So we got the project duration is 25. Okay, we got the project duration is 25. So then we do the backward pass. We go from here 25. So 25 comes here. 25 minus 7 is 18. 25 minus 6 is 19. And then here is 19. Here is 18. So when we come back, we take the minimum. So here is 18 minus 4 is 14. This 19 comes here for E. Minus 6 is 13. Then for B is this 13 comes here, minus 7 is 6. And for C is we have 13 for E and 14 for here. For F, so we take the minimum. 13 comes here, minus 8 is 5. Okay. For D is 18 comes here, 18 minus 11 is 7. So then here is for D is early start is 7. Date start is 7. For C is 5. For D is 6. So 5 comes here. Minus 5 is 0. Okay. So we find the early start, early finish, late start, late finish. Then we should find the total float. Okay. And then we mark the critical path on this diagram. So now you can remember that when I solved this problem on the notice board in the class. So we were doing all these things, showing the critical path. But here now, we see like how many paths we have at this point. So from this diagram, we can put those paths. Say for example, one path is like A, B, E, H, and P, a project finish. Okay. Other path is A, C, E, H, this line. Another path is A, C, F, H. Okay. Another path is A, C, F, G, and project finish. Another path is A, D, G, like this way. Okay. So these these paths are shown here. These 5 paths with like without any crashing. So first path was this is A, B, E, H. A, B, E, H. So A, B, E, H. So it means this 5 plus 7 plus 6 plus 6. So we got this, this is the way we got this total 24. A is 5, for B is 7, E is 6, and H is 6. So when we add, so we got 24. Similarly, on A, C, E, H. Okay. A, C, E, H, like A is 5, C is A plus 8, plus E is 6, plus H is 6. Okay, so when we add all these, we got a 25. Okay, so this path is A, C, E, H is 25 total duration. And similarly, path A, C, F, H, and then project finish. Okay, so 5 plus C is 8, F is 4, H is 6. When we add up this one, so we got 23. Okay, 5 plus 8 plus 4 plus 6, so we got 23. And then A, C, F, G. A, C, F, G. Okay, A is 5, C is 8, F is 4, G is 7, and then by this way we got 24 here. So ADG is we have 5 plus 11 plus 7, so we got 23. Okay. This is you can work out by yourself. So you will see that these are the paths like without any doing crashing. So we have A, B, E, H path 24 for 4 days, A, C, E, H 25 days, A, C, F, H 23 days, A, C, F, G 24 days, and A, D, G is 23 days. So what is the maximum is A, C, E, H. So A, C, E, H, like that. If you draw the diagram and find the critical path with zero total floats, so you will find that A, C, E, H is the critical path. A, C, E, H. This is the way we got it 25. Okay. A is 5 here, 13 here, 19 here, 25. Okay. So this is the path that gives us a critical path. Okay. So it means we should reduce, cut 1 day from this path. Okay. So going for this, we have to first go to this also, like we will build this table. In this table, we put here overhead cost is 120 per day. Okay. And activities A, B, C, D, E, F, G, H, and duration normal and crash. They were given. So we enter the same values 5, 7, 8, 11, 6, 4, 7, 6, and crash duration is this one. And then cost was also given to you, normal cost and crash cost. Okay, so this was given to you, normal cost and crash cost. So we can see the difference of the duration. And this column is a difference of duration, like 5 minus 4, we got 1 here, 7 minus 5, we got 2 here, 8 normal duration minus crash duration. 8 minus 5, we got 3 here, 11 minus 7, we got 4 here, 6 minus 4, we got 2 here, 4 minus 4, we got 0, 7 minus 5, we got 2, and 6 minus 5, we got 1. Okay, so we put the difference of the duration. Okay, delta D or delta difference between the duration, normal duration minus crash duration. Okay, normal duration minus crash duration minus minimum duration. Then cost difference. So cost is because these are direct costs given. Okay, so direct cost is more always. Crash cost is more, normal is less. So we take the difference of these costs. 600 minus 500. Okay, 500 minus 350, 150. 920 minus 800, 120. So 1,400 minus 1,200, 200. 700 minus 600, 100. 500 minus 500, 0. Okay. 1000 minus 700, 300. Okay. 420 minus 300 is 120. Okay. Then we make this, so we have delta duration and delta cost. Okay. The cost difference. Okay. Duration difference and cost difference. Then we divide cost difference with the duration difference. Okay. We divide cost difference with the duration. Like 100 divided by 1, we got 100. 150 divided by 2, we got 75. 120 divided by 3, we got 40. 200 divided by 4, we got 50. 100 divided by 2, we got 50. Okay. So 0 divided by 0 is nothing here. 300 divided by 2 is 150, and 120 divided by 1 is 120. Okay. So this is like the normal days cut 0. So what we have find with the previous duration, when we first in cycle 1, like when we did this, so how much is the duration here? 25. 25 same, like 25 is with A, C, E, H. Okay, so you can go to the diagram and see this diagram. A, C, E, H, and project finish. So this is the way we got a 20. This is our critical path. Okay, you need to find the total float, and then you can find make it color like double line for this diagram, and this will be a critical path. So we have to cut 1 day from this path. Okay, now we put these we go back to this days cut is 0, project duration we find is 25. Increase cost here is nothing, 0. So now we add up the all these cost which are like we call it the normal cost. Okay. So normal cost 500 plus 350 plus 800 plus 1200 plus 600 plus 500 plus 700 plus 300. So this will come 4950. This will come this column add all the direct cost. So this column will be 4950. Now we know that duration is 25 days. Per day cost is 120. So we multiply 25 multiply by 120. So this will come to 3000. This will come 3000 there. So then we add up a direct cost and overhead cost. Okay, so direct cost and overhead cost, these two columns. So 0, 5, and 9, and 4 plus 3 is 7. So 7,950 total cost. This is like without zero cycle, we have this the cost, and this is our duration. Now we see what is our critical path. Our critical path is if we go back and the first like this is the before crashing. So ACEH, ACEH, and the diagram is like ACEH. This is our critical path. Okay, so this is our critical path. Now among ACEH, from which activity we should cut the number of days. Okay. To decide this, we have to see where is the minimum least cost increase, minimum increase in cost. So we have A, C, and E, and H. Okay, A is 100, C is 40, E is 50, and H is 120. So 40 is minimum. So it means we should cut the number of days where increase in direct cost is minimum. Okay, increase in direct cost is minimum. So we are going to cut 1 day from C. We are going to cut 1 day from C. Okay. So now go back to your diagram, and you will draw the first like the critical path, and then cut 1 day from C. Okay, cut 1 day from C, because on the critical path A, C, E, H. Yes, so C is at point C is the minimum cost, direct cost is minimum is at C. So we cut 1 day from C. Okay. So when we cut 1 day from C, in practically you have to go back to this diagram. So instead of cut 1 day, because this is the critical path A, C, E, H. Okay, and project finishing. So we cut 1 day from C. So if, instead of 8, it will be 7. Then with the 7, we will do the forward pass. Okay, so 5 plus 7 is 12. And here comes 12 here. 12 plus 6 is 19. And then here is 12 plus 19 plus 6 is 24. So then project duration will become 24. Okay, so here we have 7. So it will be like 5 plus 7 is 12. Then here also it will come 12 here. 12 plus 4 is 16. And then this 16 plus 7 is become 23. So this path will affect like this way, you know. And similarly, because here is 19, here will be, so you have to put total duration by this way will become, when you draw this diagram again, so project duration will become 24 days. Okay, by cutting 1 day from C. Okay, you need to draw by yourself. Okay, on your paper. So cut 1 day from C and find the duration of the project. So it will be 24 days. So once we have 24 days, it means now this is like we are going to cut 1 day from C, and after cutting 1 day, so it will be cycle number 1. Okay, so like we cut 1 day from C. So how the duration when we cut 1 day from C, how total duration coming for each path A, B, E, H will be 24 days. If we add A, C, E, H will be 24 days. A, C, F, H will be 22 days. A, C, F, G will be 23 days. A, D, G will be 23 days. Okay. So this is like cycle number one. Okay, before was a this was a before crashing start. Okay, normal or zero cycle. Okay, so this is your first cycle. First cycle, put those digits that where we have cut 1 day from C. Okay, and see what has happened to the diagram. So you will see that when you see this diagram, so then you are this is critical path when you cut 1 day from here. So then this also, because here will become 12. So this path will also become critical. This path A, B, E. Okay, this path will also become critical in cycle number one, and so total duration will be 24. Okay, so this is the way, if I go back here in this, so we cut 1 day here, we put 1 day, days cut is 1 day. Okay, from the critical path, we reduce 1 day. Then total duration, project duration has become 24 days. Okay, so how much direct cost has increased? 40. Okay, we increase cost, we put 40 here. 40 plus this 4950. 40 plus 4950, it will become 4990. Okay. Now 24 multiplied by 120. 24 multiplied by 120. So this overhead cost will reduce to 2,880. And then we add direct cost and indirect cost. So total cost will become 7,870. Okay. So once we have cut 1 day from C, and next time, so we have to see from where we are going to cut, because now you when you go back to this diagram, so you are this will be critical path, and other this will also be critical path. Okay, so there will be two critical paths. So what you are going to do is you are going to see where is the minimum. So you can cut in cycle 2 1 day from E. Okay, because the cost, direct cost, when you see both the path, so direct cost will be minimum at E. Okay, so E duration will reduce to 5. Okay, so before you have here, because we cut 1 day here, so it will be like before here 12, 18. So now we will put a 12 and cut 1 day here, so it will be 12 plus 5, it will be 1217 here. Okay, similarly, other is will be 17, and 20 plus 6 is 23. So duration will become, instead of 24, it will become in cycle 2, 23. 23. So this is like the way they are going to with one cycle with this is after one cycle duration look like this way. So it means now you have two paths this one. So it means we have to cut both from, that's why we cut from E, because E is common in both the path. So then and second it look like this way, that when we cut from E, so total duration A, B, E, H will become 23. Similarly, A, C, E, H will become uh, will become 23. So with cycle number 2. Okay, cycle number 2. So you can you can add up that duration that you have on the diagram. Okay, on the diagram, the total duration will become 23, 23, 22, 23, and 23. So it means now four places is 23. So total duration, and you will see that in the second your diagram, this diagram will become this path is already critical, this path is already critical. So when it comes to 23, so then you apply that also here. So this path will become critical, and so in cycle 2, this path will also become critical. Okay. with 23 duration. Okay, with the 23 duration. And then, by this way, we complete the second cycle. And with the second cycle, what we did is we cut 1 day from from E. Okay, when we cut 1 day from E, so in our table, it will look like that we cut 1 day from E. So we cut 1 day, and total duration has become 23. So how much increase in direct cost is 50? We put 50 here. 50 plus this 4990 is 5040, and then 23 multiplied by 120. So it comes 2760. That will become total. So now when we have this in the second cycle, this was with zero cycle. This is column is with one cycle number one. This is cycle number two, and this is now third cycle. Okay, when we see these, so we have to see from where we will cut how to reduce the duration further. So it's better to cut 1 day from A. Okay, so because A is the starting activity, so by this way you can reduce the duration to 22. Okay, you have to work out on the diagram for cycle three. For cycle three, when we cut 1 day for A, duration was 5. Now it will become 4. Okay, so then we draw the diagram again, and in the diagram it will look like that duration has reduced to 22. Okay, so 20, how much increase in direct cost is 100, and how much? So 100 plus this 5040, this 5140 plus. Then it's 22 multiplied by 120. So overhead cost will become 2640. So we add up, this will become this cost. Similarly, we go with the other cost. So here, because they try, let you to understand that if we are uh, like here, wherever we can do, like here we have just 1 day, so it means we can just cross 1 day. Okay, for C we can cut 3 days. Okay, for D is also we can cut have 4 days, we can reduce. Okay, for E is 2 days. So similarly, we will see where is the critical path, then we have to cut because then three paths become critical. So we have to cut 1 day from C, 1 day from D, and 1 day from E. Then we can have reduce 1 day of the project duration. Okay, so cost has increased. When this cost has increased, here is 7,800, 7,880, and 7,800. Okay, so this cost has increased. Okay, so this is 7,780. This is the minimum cost. It means least cost and optimum duration. Okay, if you can find this, that will be great. Okay, and this is but for here they are completely crashing this schedule. It's how much maximum duration we can reduce, and then how much cost will increase. Okay, so if with 18 days cost will be 8,100, but with 22 days cost will be minimum. Okay, so this is our actually that the way we have to find least cost and optimum time. Okay, least cost and optimum time. So up to 3 cycle, when you find the least cost and optimum time, you can stop. Okay, cycle number 4, you can try one, and if it's increased, you can stop. Okay, you can stop. So for cycle 4, we have to cut 1 day from C and D and E. Similarly, others going on. So this is like they have shown here. This is your before crashing duration. This is the cycle number 1, cycle number 2, cycle number 3, and cycle number 4, 5, 6, 7. Okay. So here, like this is cycle number 0, and this 1, 2, 3, 4, 4, 5, 6, and 7. Okay. So, but you can stop in your exam here when you are able to find the optimum time and the least cost. Okay, least cost. So with this, so we are going to move next. Now scheduling compression using computers. Okay, when we work with Primavera, so now they are putting some hints. There is no fully automated process. Okay, so when we work with Primavera, there is no fully automated process. Start with the normal duration with the normal cost, producing the normal finish date. Okay, this is what we start with, the normal duration and normal cost and normal finish date. Okay, so like the zero cycle. Okay, so then when impose finish date, okay, if we impose finish date, so negative float will appear. Okay, this we have learned in the previous chapter, that start shortening the critical path by picking the activity with the least cost per day. So we will put choose where direct cost is minimum. Okay, so then we will start shortening the duration from that activity where the increase in direct cost is minimum. Compress by 1 day at a time or number of days or X number of days in one step. Okay, so just like you have seen in previous examples, like when we were giving example like this way, here, okay, here like we can reduce 2 days. So if so usually it's better to go 1 day each time. Okay, it will not make a mistake. But if there is a clear indication, so at a time also you can cut 2 days in this one. So this is what he is going to mention here over there, that compress 1 day at a time or a number of days in one step. Okay, so keep going as in the example till reaching the target. Okay? Till reaching the target, where we want to go. Okay, so schedule compress use a computer, create a spreadsheet displaying all activities, their normal and crash duration along with their normal and crash cost. Okay, so this is like you can make a spreadsheet in Excel. um, so do a regular critical path method schedule and determine the critical path. So we will determine the critical path the in the Primavera, and make a backup copy of the schedule. So we will make a backup copy and then enter the imposed finish date and schedule the project. You will notice the appearance of the negative float. Okay, so with the imposed finish date, there will be a negative float. The critical path is the one with the most negative float. Okay, so critical path will be that where the negative float is the highest in the computer. You may want to print a logic diagram filtering out the activities with the high float. Okay, so you can see a logic diagram and where with the highest float. Start shortening the critical path by picking the activity with the least cost per day. Okay, so where direct cost is a minimum. Reduce the duration by 1 day and note the effect on the critical path. So see the how your critical path is going, what is going to happen with the diagram. Okay, so you need to update the diagram actually, the way I did in the class. All activities with the maximum active float in absolute value have their float reduced by 1. Okay, move to step 7. Okay, if you find this. In case some activities maintain their maximum active float, you may have to crash another activity instead or in addition. So if there are like parallel, we have to crash both activities. Okay. So we go to step record new duration and cost in the spreadsheet of step 1. Same. So you can crash the schedule by more than one day, say X days. This is also possible if it's not going to make like curve is clear. Your project decreases in duration is Y. So your project like it's going to on the bikes, it's going to reduce. The more you crash, the more difficult and more expensive it becomes to crash. Okay, so when you crash more and more, so it will be like more becoming more expensive. The cost is going to increase uh, after the optimum duration. Okay. Stop when you achieve your goal. Okay, stop where you want to, like you want to hand over the project, so you want to according to your contract. Okay. So minimum cost or minimum duration. So we need to prefer what we are looking. Are we looking the minimum cost, or are we looking the minimum duration, or are we looking optimum duration and minimum cost? Okay, projects final thoughts. Project acceleration should be based on scientific and systematic principles. It is not random dumping of extra resources on the site. So see, it's not like you are wasting your resources by accelerating the project. So it's a very wise thing, and go systematically in the process to shorten the project. It is not a race to set record. Okay, so like that, we are not making a competition with the other to just to make a record, to make a duration minimum. So we have to follow according to our project. It should be done only to the extent needed. Okay, so this acceleration you can do until what time it's suitable for, you know. You cannot accelerate all your projects, prioritize them. So you make a priority which project you want to accelerate. Okay, so there are physical and practical limitations to project acceleration. So when you do the acceleration, so see, there is a lot of things that you have to look. Unplanned or unorganized acceleration may result in delays. So if we create mess, so there will be even we want to shorten, but it will create delay, or it will increase the higher cost. Okay, or there will be a quality problem if we not maintain the proper quality, just putting the more importance on speeding up the project. We will do maybe wrong work or in the wrong way. So we have to dismantle, we have to do the rework. So avoid these things whenever you do the shortening or reduce the duration. So we have to maintain the quality, and there should not be a rework problem, or we have to dismantle and do the work again. More variation orders and claim. Okay, if we are creating mess, there could be more change orders and claims from the contractor side. So avoid chaos for safety issues. Okay, so don't make duration unrealistic, and then for people it will be, you know, everybody will be like under pressure to hurry up, and there could be accident can happen, you know. So avoid these things also. So this topic continue. Not all subcontractor crew or activities need to be involved in the acceleration. So we have to see wherever we can do the acceleration. Project contractors acceleration without owner's approval may lead to problem. Okay, so whenever you have to take in confidence the owner, you know, that what you are going to do, you know, for acceleration of your project. Owner's target finish date may be revised during construction, but other parties must be informed. Okay, so whatever the target date, owner, so take confidence, make a negotiation, and then decide, and then go move ahead with your project. So optimum scheduling, like where we have the least cost and optimum duration, like the most suitable duration with minimum cost. Okay. Optimum scheduling is selecting the project starting point and composition of the durations and timing of its activities that will result in optimum schedule and least cost. Okay, so that will result in a optimum schedule and least cost, like in your previous example. So 22 days is the optimum duration where we got the minimum cost, okay, least cost, while maintaining the project scope and quality. Okay, so remember that acceleration doesn't mean we should reduce the scope. Project scheduling in areas with the extreme weather should be managed, keeping in mind the weather variations. So when we are dealing with like in situations where there is a problem with the weather, so we have to build our project accordingly, and we have to adjust suitable scheduling. So that's it. We finish this work. It has taken first. I thought I should complete it in two parts. Then, but I finished it in one part. So it's almost 1 hour, more than 1 hour, 20 minutes. You know, Video. So thank you very much for your attention. I hope this will help you in your exam. So with this, allow me to say, سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت نستغفرك ونتوب إليك. Thank you very much and see you next time, inshallah.